For this video, we are going to be discussing right triangles and the Pythagorean theorem. So what is a right triangle? A right triangle is just a triangle that has exactly one 90-degree angle. So right here we have an example of a right triangle. So, some vocabulary we need to discuss. The two shorter sides of the triangle are what we call the legs. And together, the legs make up the 90-degree angle. And we always represent them with the letters A and B. The longest side of a right triangle is called the hypotenuse. And we always represent that with the letter C. You can always tell which side is the longest because if I take the 90-degree angle and I look directly across from it, that will always be my longest side. So that's a right triangle. Now the Pythagorean theorem is this really ancient math concept that describes the relationship between the three sides of a right triangle. And the way it works is this. If I take A and I square it, and I take B and I square it, I get C squared. Okay, A squared plus B squared equals C squared. For example, if I told you that A was 3 and B was 4 and C was 5, well, then I could say, well, 3 squared plus 4 squared equals 5 squared. 3 squared is 9, because that's 3 times 3. 4 squared is 16, which is 4 times 4. 5 squared is 25. 9 plus 16 is 25. So if I square A, square B, add them together, I get C. So we can use this relationship to solve some problems with right triangles. So let's take a look at some examples. Example 1 says find the length of the missing side. So I know that this side length is 12 and this side length is 5, and I want to find this missing side. Well, here's my right angle, and my missing side is across from it. So I know that this is my hypotenuse. Oh, that was weird. I'm going to label it C. So my goal is to figure out what is C. Well, I know by the Pythagorean theorem that A squared plus B squared equals C squared. So I can set that problem up. Now it doesn't matter which one of these I call A and which one I call B. It's not going to affect how we do the problem at all. I'm going to say that 5 is my A, and 12 I'm going to say is my B. So now if I plug these in the Pythagorean theorem, I get 5 squared plus 12 squared equals C squared. All right, well 5 squared is 25. 12 squared is 144. So 25 plus 144 equals C squared. Add these two together, I get 169 equals C squared. So to figure out what C is, all I have to do is take the square root of both sides. The square root of 169 is 13. So my missing side length is 13. All I did was plug my numbers into the Pythagorean theorem and work it out. Okay, let's try another example. Example 2, we want to find the length of the missing side in this problem. Well, in this problem, I see that 20 is across from the 90-degree angle, so that's my hypotenuse, that's C. And then my legs, B and A, are 16 and X. So I'm trying to figure out what X is. So if I take these and plug them into the Pythagorean theorem, I've got A squared plus B squared equals C squared. I know what C is. I know what B is. I don't know what my A is, so I can say, well, X squared plus 16 squared equals 20 squared. Since X and 16 are my legs and 20 is my hypotenuse. All right, next step, I'm going to square these two things. 16 squared is 256. 20 squared is 400. So now I've got a two-step equation here. I've got x squared plus 256 equals 400. So my first step is going to be to subtract 256 on both sides. If I do that, I get x squared equals 144. Now I take the square root of both sides, and I get that x equals 12. All right, so all I did was plug in the two side lengths that I know and find the one that I'm missing. All right, so no big deal, just becomes a two-step equation. All right, let's take a look at a third example. It says, do the following side lengths form a right triangle? And I've got 5, 6, and 11. All right, so if they form a right triangle, then I know that if I take a squared, add it to b squared, I should get c squared. So which of these side lengths have to be a, b, and c? Let's start by coming up with c. C always has to be the biggest one. So in this case, 11 is my c. A and b, it doesn't make a difference. They can be either one. I'm going to say 5 is a and 6 is b. So now I need to plug these three side lengths into my equation here and see if it's true. If it's true, if it works, if I square these and they equal squaring 11, then these do form a right triangle. If it's not true, then they do not. So let's plug them in. We got 5 squared and 6 squared and 11 squared. 5 squared is 25, 6 squared is 36, and 11 squared is 121. Add these two together, I get 61. Now, 61 does not equal 121. So, these do not form a right triangle. The answer is no, they don't form a right triangle. Okay? One pair or three sides that do form a right triangle is if I was to say use 9, 12, 15, 9 squared plus 12 squared and 15 squared. 9 squared is 81. 12 squared is 144. 15 squared is 225. 81 plus 220 or plus 144 is 225. 225 equals 225. So these would form a right triangle. All right? And if they form a right triangle, there's this vocab term for them called a Pythagorean triple. So three numbers that form a right triangle are called a Pythagorean triple. So for example, 9, 12, and 15, they are a Pythagorean triple. 5, 6, and 11, they are not a Pythagorean triple. All right, so your try it problem for tonight is to find the missing side. So given 7 and 24, you need to find the missing side here. So simply plug 7 and 24 into the Pythagorean theorem and see what you get.